Okay, in this video, we're going to identify whether a piecewise function is continuous or not. I'm going to show you how to identify whether it's continuous. Now, I mentioned earlier that there are two criteria for identifying whether a piecewise function is continuous, and they are right here. Okay, two conditions to be continuous. The domain has to be negative infinity to positive infinity. Otherwise, there's a break. Continuous means without a break or without stopping, okay? And so if there is a break in the domain, then the piecewise function is not continuous. But if the domain is negative infinity to positive infinity, the other important thing is that both pieces have to be equal. They have to have the same output value at the transition value, okay? So here on this first one, which we did previously, the transition value is 4. But the problem is that 4 is not included in the domain. Because the domain does not include 4, this piecewise function is not continuous. So we're just going to say right away, not continuous, okay? Because it does not, the domain is not continuous, okay? So now let's go down here to h of x. The domain here is negative infinity to positive infinity, and therefore this h of x might be continuous. And then the only other thing we have to make sure is that the transition value 6, when we plug 6 into both pieces, if we get the same number, okay, if we get the same number, then this piecewise function is continuous. So let's go ahead here and we'll plug 6 in. So we'll have 6 squared minus 12 times 6. Well, 6 squared is 36. 12 times 6 is 72. And 36 minus 72 is negative 36. Okay? Down here, if we have 6 minus 30, okay, 6 minus 30 is negative 24. And since negative 36 does not equal negative 24, then h of x is also not continuous. All right. Let's try a couple more examples. All right, here we have a piecewise function, g of x. And the first piece is x plus 5 when x is less than or equal to 3. And the second piece is 11 minus x when x is greater than 3. Okay. Well, the domain of the first piece here is pretty easy to identify. The domain is all numbers less than or equal to 3. So that's negative infinity up to 3 inclusive with a bracket. The domain of the second piece here is all numbers larger than 3. So we're going to start at 3 and we're going to go up to infinity. And you can see here that the domain goes from negative infinity up to 3, including 3. Then it starts just above 3 because it doesn't include 3, and it goes up to infinity. And therefore, the domain here is, the domain of the whole piecewise function is negative infinity up to infinity. So we've satisfied condition 1. Condition 2 is what are the output values at the transition x value. So the transition value is 3, and so we're going to plug 3 in here, and we get 3 plus 5, which is equal to 8. And then we're going to plug the 3 into this 11 minus x. 11 minus 3 is also equal to 8. And since 8 equals 8, then the piecewise function, g of x, is continuous. Okay? All right. Let's try another example. Okay, here's a piecewise function that we did previously. Look at the domain. We identified the domain previously, and you can see that there's a huge gap in the domain. We have all x values up to negative 3, and then we leave out all the x values between negative 3 and 2, and then we have all the x values larger than or equal to 2. So there's a whole bunch of x values that are left out. That means the domain is not negative infinity to positive infinity, and therefore this piecewise function automatically is not continuous. Okay. Let's try another example. All right, here's another one. f of x is a piecewise function. It has two quadratic pieces. One of them is a negative quadratic, and so that we know that it's a parabola that's turned down, and this one is a positive quadratic, so it's turned up. But let's go straight to the domain. Here, the domain of this piece is all values of x less than 0. The domain of this piece is all values of x larger than or equal to 0, and because it's equal to 0 and this one's less than 0, that means that the domain of this piecewise function. All right. So the domain is negative infinity to positive infinity. Now we just need to see if the two pieces match up where x equals 0. Okay, so we're going to plug 0 in here for x. So 0 plus 3 squared plus 2 is, well, 0 plus 3 is 3. 3 squared is 9. And 9 plus 2 is 11. So that's our number, 11. Here we're going to plug 0 in. Negative 0 squared plus 11. Well, 0 squared is 0. Negative 0 is 0 plus 11 is 11. And sure enough, we got an 11 here. We've got an 11 here. They do match up. And since the domain is negative infinity to positive infinity, f of x is continuous. Okay. All right, well, there's a few examples of how to identify whether a piecewise function is continuous or not continuous.